Today, let's talk about some of math's properties. These are properties that will be true for all numbers in math. Some properties that you probably already know, some things that you might look at and say, well, no, duh, I knew that. But we're going to put some names to them, and it's important that you remember some of these names. These properties are true for all real numbers in math. And since you haven't learned any fake numbers yet, well, then they're true for all the numbers that you know. So let's look at our first property here today, and that is the additive identity property. All the additive identity property means is what number would you add to A to make it equal itself? And the answer there is 0. For that reason, we call 0 the additive identity. So, for instance, if you were to see 5 plus 0 is equal to 5, that's demonstrating the additive identity property. If you have $5 in your pocket and I give you none, you still have $5 in your pocket. Just like with the additive identity, there's also multiplicative identity. What would you multiply A by to make it equal itself? The answer there is 1. If you multiply any number times 1, it equals itself. It does not change. It remains the same number. It stays unchanged, so we say it keeps its identity. Some properties that are very similar to the identity properties are the multiplicative property of 0 and the multiplicative inverse. It's a fun word to say, multiplicative. Multiplicative. And I like to call this the no-duh property, because anytime you multiply a number times 0, it is 0. Any number times 0 is, of course, 0. Branching off of this, we can say, if you're multiplying a number times a number that we don't know, and it equals 0, well then obviously that number that we don't know, we can solve for. It must be 0. And we can say we know this because of the multiplicative property of 0. Kind of along the same lines, there's the multiplicative inverse. One key word here you should know that goes along with multiplicative inverse, kind of a synonym to that, is reciprocal. What number would you have to multiply 3 by to make it equal 1? And the answer there is its multiplicative inverse, or its reciprocal. To find a number is reciprocal, simply switch its numerator with its denominator. So the reciprocal of A over B would be B over A, which means the reciprocal of 3 would be 1/3. So if I wanted to find the multiplicative inverse of 2/3, what number would I multiply 2/3 by to make it equal 1? Answer there is its reciprocal, or multiplicative inverse, 3/2. Math is really famous for this, for assigning a different word that means the exact same thing, just so that way you have to remember more things. The distributive property is actually so important that it gets its own section. All of Chapter 1, Section 5 from your textbook is devoted to the distributive property. For any real numbers, A, B, and C, this will always be true. When dealing with a sum or difference, grouped together in parentheses, if I want to multiply it by a constant or a variable, it is true that both both quantities here on the inside of the parentheses will be multiplied by the quantity on the outside. So I can distribute C to both A and B. So an equivalent expression to this one would be C times A plus C times B. The distributive property is particularly useful in trying to compute mental math. For instance, if I wanted to calculate 17 times 99, well, I could reach for my calculator, or I could just recall that 99, an equivalent expression for 99 is 100 minus 1. And I know that the distributive property, that an equivalent expression for this would be 17 times 100, or 1700, minus 17 times 1, or 17. So the answer to 17 times 99 will fall just 17 short of 1700, which is 1683. Can you think of your own example of how you could use the distributive property to solve a mental math problem? Please bring your own example tomorrow to class of how you could use the distributive property to solve a mental math calculation. My personal favorite here is the commutative property. Think of the key root word here, commute. Your parents might have to commute to and from work, meaning they have to travel from one place to another. My question to you here is 3 plus 2 the same thing as 2 plus 3? Don't 3 and 2 just merely switch places? They commuted with each other. So I can say very simply that the commutative property is any way that I demonstrate that A plus B is equal to B plus A for any real numbers, A and B. This is true for addition, so we have the commutative property of addition, but is this also true for multiplication? Well, is 2 times 3 the same value as 3 times 2? Ah yes, they both equal 6. This will always be true for addition and multiplication. So from this, we have two properties: the commutative property for addition and the commutative property for multiplication. Please remember that there are two properties that come out of this one, the commutative property. Finally, your last property, which many people get confused with the commutative property sometimes, is the associative property. Just like the commutative property, there is an associative property of addition and an associative property of multiplication. The associative property of multiplication says that if you are adding two numbers together and they are grouped with parentheses, and then you add another number, if I change which numbers they associate with, for instance, I just move the parentheses to say maybe A plus B plus C. I've changed which number B associates with. Here B associates with A, and here B associates with C first. And the associative property says that no matter which way I do this in, I will always get the same answer. For instance, if I have 2 plus 3 plus 5. Does it matter whether I add 2 to 3 and then add 5? Or could I add 3 to 5 and then add 2 to it? Because according to this property, the associative property of addition, it does not matter which way I add in. It does not matter which way I group. You can see it's very closely related to the commutative property, but it's not about switching the order of numbers. It's about switching which number they associate with first. This is also true, of course, for multiplication. If I'm multiplying 2 times 3 times 5, does it matter which order I multiply these in? No. I can multiply 2 times 3 and get 6, and then multiply by 5 to get 30. Or I can multiply 3 times 5 and get 15, and then multiply by 2 to get 30. So either way I cut it, I can change which numbers associate with which. I could even change this up so that I multiply 2 times 5 first, and then multiply by 3. This is again very useful for mental math, because it might be easier to think about associating 2 with 5 and then multiplying by 3. Some students might find it easier to think about associating 3 with 5 first and then multiplying by 2. Well, I hope that you had as much fun today listening to the properties as I had talking about the mathematical properties. Just remember that these properties that we talked about today are true for all real numbers in math.